Okay, welcome all. So low latency reality check. So low latency is probably the hottest topic in the industry today. Probably half of the talks that have been going on here are in some way connected to low latency. So with all these promises, I would like to give you an update on what the real situation is on the market. Can you adopt it, and what protocols do you need to employ in order to build out a low latency solution there? So I'll be giving a small review of the different protocols. Second part is very important. It's low latency is all about trade-offs. So we'll discuss the different trade-offs that you will have to make. And finally, I'll give a little view into the video player challenges. So we as a video company have encountered many of these challenges. I'd like to share some of them with you if you are interested in building out your own low latency player. So a little bit about THEO player. We are a pure video player company. We don't do any encoding or packaging or analytics or what have you. So we purely focus on building the best video player out there. We have a very broad platform reach, a very big feature set, and we integrate with many of the ecosystem partners. So what we see when we build out enterprise video end-to-end solutions, most of you will, in some way or another, already have an analytics provider and a DRM provider. And so what we prefer to do is to pre-integrate with these partners so that the adoption of our player is much more smooth. And we do that across all the platforms that we support. So about low latency. So if we look a bit at the low latency regime that we see here, when we have traditional streaming, which is about this area here, anywhere from 60 seconds to 20 seconds, I'll round it off. This is what you get on regular Asch or HLS streaming today, given the size of the segments that you need to employ for HLS and what the recommendations from Apple are, and propagation through the CDN, it all takes time. So this is a bit of the regime where we can expect this. Now, what we say here, HLS tuned, dash tuned, there are ways to decrease that end-to-end latency using regular MPEG dash and regular HLS just by playing with the segment size. So there we might see anything, this is a bit pushing it, honestly 8 seconds to 15 seconds, that's a bit of the regime where you might be finding yourself in if you adopt this. Now for many applications that is just fine. So if you're live streaming, you're not necessarily need to have that 1 second latency. What you might prefer is to have a higher quality of experience, so spend more compute cycles on encoding, make sure that your client buffer is big enough so we don't get any rebuffering issues. So for many applications, that's actually a lot more important. Now, if we talk about the low latency specific protocols that we see arriving on the market today, we are talking about low latency regime anywhere between 2 and 5 seconds. This is where low latency HLS, low latency chunk CMAF or CMAF CTE, goes by many other names, and some of these proprietary protocols that we see arriving as well. But if you go sub-seconds, we are more talking about UDP-based streaming protocols, which are not supported other than WebRTC in web browsers. So this is a reason why we do not, as a video player company, have adopted WebRTC. And I'll explain a little bit more in detail. So WebRTC is playable in HTML5 browsers. There are a few other disadvantages to using HLS WebRTC. So if you look at WebSockets HLS CMAF CTE or low latency HLS from Apple, the new spec, these are all supportable on HTML5 playback, which is still a rather important platform to support in all browsers. So probably what we see our customers is about half of the content being available on web browsers, but we also see many clients who actually build out a browser-based app, so a progressive web app, and then you need that HTML5 playback again. Other companies will adopt a native solution on iOS and Android, similar. So there you might choose to do UDP for low latency protocols. RTMP, which has been the streaming format to go for a decade ago, I guess, it's been dying because Flash is no longer supported. I have seen a notice on my Chrome that it will be officially closed down January 2020 in Chrome, so no more Flash fallbacks. So what about the latencies? Well, first of all, regular HLS dash, if you tune it, you can get anywhere 8 to 16 seconds, so we call that medium latency range. Chunk CMAS CTE, we call that low latency. I have run tests that range anywhere from 2 to 5 seconds to 5 or 6 seconds. It depends a little bit on how much time you spend encoding, your segment size, your client buffer size. You can push it down to 2.5 seconds if you want to. So LLHLS, we haven't played around with it that much. The specification is still in review. At the closing talk, the people from Apple will be giving an update on the changes that will be coming in this protocol. There is a lot of industry backlash against this protocol. I might go into a little bit more detail if you have any little bit of time in the end. But what we see, WebRTC is really the sub-second latency, and you hear a lot of companies talk about that. Now, why do we think as a video player company, or at least for our customers, that we do not want to support it? It does not support DRM. It does not support multi-bit rate. It has no quality assured delivery. That means that it's UDP-based protocol. If you're going to drop packets, you're going to have artifacts in your stream. And it's not cacheable on HTTP. What does that all mean? That it might be scalable to 1 million people, but it's going to cost you a fortune. So you will hear people talking low latency sub-second to millions of people, for sure, but your network bill is going to go dramatically. So we think this is surely has its particular use cases. If you look at smaller audience where you want to do betting or online auctioning and your audience is somewhat in the range of a few hundred to maybe a few thousand, it's certainly a very viable option. We have not chosen to support that. What we do support, however, is of course the HLS dash regular and tuned version, dash CMAS CTE. So that's really the first low latency dedicated protocol that has been deployed in the market today. We have customers running this in production, and it's fully standards based. So you will find many partners out there who do encoding and transcoding and packaging that will support this workflow for you. So that's available today. It allows for multi-bit rate playback. It supports DRM. It has full control over startup logic. There is quality assured delivery because it's a TCP-based protocol, and the best of all, it is exactly scalable in the same fashion as regular streaming content. So your CN bill is not going to go up very much. I've talked to CDN providers who will say there's a little bit more overhead incurred, but they will not charge them to the client. So the end-to-end bill that you need to pay to build out a low latency streaming solution with this technology, comes down to what you have today. So a little bit about LLHLS then. So same qualities apply. Theoretically, this protocol. So this is a spec that has come out, or a first draft at least, a few months ago by Apple. It requires a few specific technologies, so we don't expect market adoption before anywhere half of next year. We might see the first real companies come out with apps and solutions based on this technology. But we're working very actively with packaging partners to explore how or if we need to optimize the workflow to support Apple low latency HLS. Now, one thing that's not mentioned here, there is a community specification for low latency HLS that is an open source contribution that has been used in Periscope. So that is fairly similar to what low latency Dash is doing. It's using chunked transfer encoding, but rather than chunked packaging, what Dash CMAS CTE does, it will actually announce segments ahead of time. So segments that do not exist yet get a special tag in the manifest, so the player knows if he is almost at the end of the live segment, he can already query and does not need to wait for that manifest update. So that's something that exists. The big issue there is there are only a few open source solutions that will support you through this workflow. So if you look at the professional service-based providers or hardware-based services, these do not support this technology. There is a GitHub repo, it's called Streamline, if you want to check it out. It works. So, yeah, it's not very visible. So what we talk about when we talk about the dedicated low latency protocols, it's Dash CMAS CTE, LLHLS, which is Apple specification, and WebRTC. Now, I will be focusing the rest of the talk a little bit on this one because that's the one that is in market adoption today. This one is still very much in the works. So, as I mentioned before, when you are thinking about deploying a low latency solution, it is all about trade-offs. So there are trade-offs to be made. I'll show the next slide. So this is actually a fairly graphic overview that will tell you that if you want the lowest latency, your viewer experience or your scalability is going to suffer. If you prefer higher viewer experience, so more compute cycles in your encoder or a bigger client buffer, then your latency is going to suffer. So it's all about trade-offs. So first trade-off, a large chunk, so probably the two biggest contributors to latency in an end-to-end video production workflow are the time you spend in encoding and the size of the client buffer. And these traditionally were determined by the segment size. Now, chunked CMAF has used chunked packaging that allows you to push out partial content and deploy that over the CD and propagate all the way to the edge and already into the client player without it being fully complete at the final chunk of the segment. So this is what this low latency chunked transfer and chunked packaging is. But if you want to have a very low latency, you're going to set your encoder settings to real time or near real time, and then either your visual quality is going to suffer or you don't achieve such a good compression, which is bad for your bandwidth. So that's something to consider. We see most of our customers prefer to go with a better quality experience. Certainly for stuff like sports streaming, you don't want to watch a crappy stream on a high-end service. So we see people spend quite some considerable time in encoding anyway. So second part where you need to make the trade-off is the size of your client buffer. So again, previously to chunked packaging, we needed to cache at least an entire segment. The Apple specification for HLS actually says that you need to cache at least 3.5 times the segment size. So on traditional 10-second segments, that was 35 seconds in the client buffer. Now for these low latency protocols, there is still a very considerable amount of the end-to-end latency that sits in the client buffer, especially, and I'll come to that in the next slide, because you need to assess when you need to make a quality switch. So, but however, using chunk transfer, using chunk encoding, or chunk packaging, the smaller chunks come in and your buffer is actually fairly predictable. And so we are, in a way, better able to maintain a smaller buffer size, but just by having chunk packaging and chunk transfer in there. So the third trade-off, that's your joint latency, or what you might compare to into traditional linear television, the time it takes when you click on your remote control and the next channel appears. So this is also in all streaming protocols, certainly segment-based streaming protocols, influenced by the size of your segment, because every segment needs to start with a keyframe, or starts with a keyframe, and that's the point where you can pick into the stream. You cannot just randomly, even with chunk packaging, you cannot just randomly pick into that segment anywhere you want to. So you need to wait for a start of the segment. So you have a choice. If we are encoding part number 4, do I choose to wait for part number 5 and reduce my end-to-end latency, or do I already start playback at the 4th segment but incurring a larger latency? So if you have 6-second segments, you might incur an average of 3 seconds end-to-end additional latency. Now there are ways on how to combat that. So you might, strategies that we employ is we will start playing back the previous segment and just slightly increase playback rate to a level that's unnoticeable to viewers and catch up to the end-to-end latency. So it's a very useful technology to employ. If you're far out of the synchronization window, you might even choose to seek out. And on dedicated devices, native platforms, it might be even more useful to download that previous segment and do a fast decode without even showing the frames. So these are strategies that you can employ to reduce your end-to-end latency, but again, you need to make that choice about your segment size. So switch latency is very similar. Switch latency is the time it takes before when your player detects that he might play back a higher quality stream, so a higher resolution, a higher bit rate, and the time you're actually playing that. So why is that important? Because you need to figure out, so here we see that we might play a higher quality, but we still have some content back in that buffer. So what do we do with that content? Do we wait until that content is fully played out, or do we just trash it? So 2 of these segments we trash them, and we play and start downloading the higher resolution already. That's a choice. Your bandwidth is going to suffer a little bit, but you need to maintain at least that active segment on which you are. So again, segment size is very important here. So as I mentioned, Dash CMAP CTE comes with chunk packaging and chunk transfer encoding. That chunk transfer encoding has some particular challenges. What is it about? Well, bandwidth measurement. So previously, when we would download a segment, we would download it at theoretical maximum network speed. That segment would be fully prepared on a CDN. We download that. We measure the time it takes to download that. We measure the size of the segment, and we have a fairly trustworthy indication of the theoretical bandwidth and adapt our ABR algorithm to that. Now, in chunk transfer encoding, that content is coming in at a rate, certainly if you're connected to the live segment, at the rate at which it's being produced, because you cannot produce those chunks any faster than your encoder will actually encode them. So all of a sudden, our classical bandwidth measurement technique no longer works. So we, as a video player company, needed to write out a very particular new ADR algorithm just to cope with this chunk transfer encoding. So this is a fairly hard task. It's not trivial. And we see that because of this, THEO Player is at this point the only video player company in the world who has a live product that will do multi-bitrate on low latency. So many other competitors will do low latency, but they will support only low quality. So this is a bit of a disadvantage. You get your low latency, but still lose everything that ABR will give you. So that's a bit unfortunate. So this is a very tricky thing to achieve. So second, timing. There are a few ways in how to know which segments are available in MPEG Dash. And one of these is based on a pure calculation where you do not need a manifest refresh, and it's called, paradoxically, it's called number mode, but it needs a timing source. So what you have certainly on HTML5 platforms, you will see that the client clock is actually not very accurate. So it can be anywhere between a few seconds off. But if your end-to-end latency, if you want it to be 2.3 seconds, you need that very accurate clock. So MPEG Dash Consortium has identified 6 different methods on how to achieve a proper timing resource. Some of them are not usable in web environments, so they're NTP based. You're not going to do that on your web player. You might do that on your native apps, but why bother if there are very good solutions that will work over HTTP. So the 2 HTTP-based methods are either embedding a timestamp directly in a manifest, which is called HTTP direct. It's not very useful because your manifest is uncacheable at that point because you need to generate that timestamp every time again. So it's not very useful. HTTP ISO actually is the URL of a time server that will serve an ISO 8601 formatted timestamp over pure HTTP web connection. So we have built a time server, which is NTP correct, that will generate a timestamp, and our client will synchronize before starting playback. He will measure the difference between the local clock and the time source in order to have an accurate estimation. Now, finally about this, and this is something that we have heard by many clients, latency is not the most important thing about this, but rather having it synchronized over multi-devices. So they want to achieve broadcast latency, but they want to have that available in sync with the television, in sync on your OTT device, your tablet, your iPhone, your web browser. So synchronization is a very important topic. It needs an accurate source of timing and a player that can adapt to these strategies. So biggest issue today, low latency. There's no support for iOS. You might technically build that, but Apple's App Store policy actually prohibits you from streaming MPEG Dash content if it's longer than 15 minutes. So the reason why is because they were building out their own low latency protocol. So low latency Apple HLS, it uses HTTP2 push, so it doesn't use HTTP transfer encoding, but pushing that content. So today, not many CDN or large CDN providers will support this. There's a lot of industry backlash against this HTTP2 push, at least in the fashion that they do it. You're gonna at least multiply by 20 the amount of requests that you make out to your CDN. So that's a big no-go. But we'll see what Apple says. So In conclusion, there is a lot more about low latency than HCI. All promises are not golden. You might deploy a solution. It's not available on all platforms yet, at least if you want it to be in a scalable and affordable fashion. It is all about trade-offs. So it's a game about trade-offs, and the solutions on the client side for clock synchronization or different multi-device synchronizations, those are solutions that are in the market today, at least from THEO player, if you are interested in such a solution. Now, final 3 slides. I'm not done yet? No? Okay. Just one big stop over at the booth. We have a new streaming protocol in the works at THEO Player Labs. It's fully HTTP 1.1 compliant, so it will scale over a regular CDN across the globe in an affordable fashion, sub-second latency across the globe, really across the globe. It will give you instant channel switching, so about the time of 1 or 2 frames, you can switch your quality or switch your switch to a new stream. So this will be available will become available somewhere in April, so we will be announcing quite a few things at NAB next year in Las Vegas. If you have any questions about that, please stop over at the booth. We have a few white papers about that streaming protocol and also about a lot of our other solutions. So we're at the showcase, booth number 3.
Round of applause for THEO Technologies. Thank you so much. Stop over to the booth if you have any questions. Go up to the front of the room and help yourself to a yellow